Alright, so in this problem, I have x minus 3 to the power of 4 is equal to x to the power of 4. So the first thing I'm going to do is subtract x to the power of 4 on both sides. So then these two cancel out, and now I have x minus 3 to the power of 4 minus x to the power of 4 is equal to 0. Now, I'm going to rewrite this as x minus 3 squared to the power of 2 minus x squared to the power of 2 is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x minus 3 squared plus x squared times x minus 3 squared minus x squared is equal to 0. And now this is the same thing as x squared minus 6x plus 9 plus x squared times x squared minus 6x plus 9 minus x squared is equal to 0, because I just expanded x minus 3 squared. So now I'm going to simplify this to 2x squared minus 6x plus 9 times negative 6x plus 9 is equal to 0. So now this gives me two equations. I have 2x squared minus 6x plus 9 is equal to 0, and negative 6x plus 9 is equal to 0. So for negative 6x plus 9 equals 0, I get 9 is equal to 6x, and x is equal to 9 over 6, which is equal to 3 over 2. So this is one solution of x. Now for 2x squared minus 6x plus 9, I have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 2, b is negative 6, and c is 9. So I get x is equal to negative of negative 6 plus or minus the square root of negative 6 squared, which is 36, minus 4 times a, which is 2, times c, which is 9, all over 2a, so 2 times 2. And now this is equal to positive 6 plus or minus the square root of 36 minus 8 times 9 is 72, all over 4, which is equal to 6 plus or minus the square root of negative 36 over 4, which is equal to 6 plus or minus the square root of 36i over 4, which is equal to 6 plus or minus 6i over 4. And if I divide everything by 2 over here, I get 3 plus or minus 3i over 2. So these are two more solutions. Alright, so in this problem, I have 8 to the power of x is equal to 80. So I'm going to first start by rewriting 80 as 8 times 10. So now I have 8 to the power of x is equal to 8 times 10. And now I'm going to go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 8 to the power of x over 8, well, 8 is the same thing as 8 to the power of 1. So I get 8 to the power of x minus 1 is equal to 10. Now, 8 I can rewrite as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x minus 1 is equal to 10. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, that's going to equal 2 to the power of 3 times x minus 1. And I can simply distribute the 3, so I have 3 times x plus 3 times negative 1. So 3 times x is 3x, and 3 times negative 1 is negative 3. So I have 2 to the power of 3x minus 3 is equal to 10. Now I'm going to take the log on both sides, so I'll get log of 2 to the power of 3x minus 3 is equal to log of 10. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, b is 3x minus 3, so if I move this to the front, I get 3x minus 3 times log 2 is equal to log 10. Now, log 10, that's actually equal to 1. So now I have 3x minus 3 times log 2 is equal to 1. Now, if I divide both sides by log 2, these two cancel out, and I get 3x minus 3 is equal to 1 over log 2. Now, if I add both sides by log 3, these two cancel out, so I get 3x is equal to 1 over log 2 plus 3. And 1 over log 2, that's the same thing as 1 over 0.301 plus 3, which is equal to 3.3223 plus 3. So I have 3x is equal to 6.3223, meaning x is equal to 2.1074. Alright, so in this problem, I have 2 to the power of x plus 8 to the power of x equals 68. So now first we write 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x is equal to 68. And I can actually switch these two. So I get 2 to the power of x plus 2 to the power of x to the power of 3 is equal to 68. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y plus y to the power of 3 minus 68 is equal to 0. And this is the same thing as y to the power of 3 plus, I'm going to write y as 17y minus 16y minus 68 is equal to 0. And now I get y to the power of 3 minus 16y plus 17y minus 68 is equal to 0. So I simply switch the places of 17y and negative 16y. And now from y to the power of 3 minus 16y, I'm going to factor out y. So I get y times y squared minus 16 plus from 17y minus 60, I'm going to factor out 17. So I get 17 times y minus 4 is equal to 0. And it's the same thing as y times y plus 4 times y minus 4. That's equal to y squared minus 16 plus 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y plus 4 plus 17 is equal to 0. And this is equal to y minus 4 times y squared plus 4y plus 17 is equal to 0. So now this gives me two equations. I get y minus 4 is equal to 0, and y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, y is obviously equal to 4, so I get one solution. And from y squared plus 4y plus 17 equals 0, you have to use the quadratic formula to solve this. And if you actually do end up using the quadratic formula, I'm not going to do it because it's a waste of time, but you get that there is no solution, but because you get the square root of a negative number, and you can't take the square root of a negative number. So y equals 4 is my only solution for y. And now remember how we let 2 to the power of x equal to y. So now if I have 2 to the power of x is equal to y, and y is 4, that means I have 2 to the power of x is equal to 4. And 2 to the power of what number equals 4? 2, right? So I get x is equal to 2. And this is my solution to this problem.